Hi everyone, here's our problem. F of x equals -5 times the quantity x minus 3 squared plus 15. Now, so the first thing we're going to do is find the vertex, and the vertex comes from the h and the k, and it's always opposite coming out from here, so 3 and 15. So our vertex is 3, 15. Our axis of symmetry is also really easy. It's just x equals 3. It's whatever the x coordinate is there for the vertex. So let's find the zeros. So to find the zeros, we're going to set f of x equal to 0. And I'm going to rewrite everything else. Now I'm not going to distribute, I'm not going to factor, FOIL, do anything like that. I am going to start adding, subtracting anything I can from this side. So we have positive 15 here. We're going to subtract 15 from each side. And now I still have this -5 hanging out in front, so I'm going to divide each side by -5. Those are going to cancel, and I'm left with 3 equals x minus 3 quantity squared. Now I have to get rid of the square, so I'm going to perform the square root. So as I'm performing the square root, I'm not going to lose the square root symbol unless I actually take the square root of 3. And that's not going to give me an integer, so I'm going to leave it as the square root of 3, but I'm going to put a plus or a minus in front, because remember, we always have those two options. We have those two intercepts. And that's equal to just an x minus 3 on this side. The square goes away when we take the square root. We'll add 3. So 3 plus or minus the square root of 3. That's what x is equal to. So this is two different values. 3 plus radical 3. That's one of the x's. And the other x is 3 minus radical 3. That's another one. So those are the two x-intercepts. Those are the zeros. And let's put those over here. So we have 3 plus square root of 3, 0. So I'm going to ask you to come up with coordinate points, 3 minus square root of 3, 0. So these are exact. Don't come up with a value for that yet. We will find that in a moment when we go to graph. And let's see, let's come up with decimal approximations now. Here is my screen, and I am going to put in 3 plus the square root of 3, get an answer. Oh, my calculator on this computer doesn't give me approximations. There we go, and let's go up. Here we go. Goodness gracious. 3 minus, I know you're all laughing and giggling at me. There we go. So 4.73 and 1.27. We'll round to the nearest thousandth. So let's go back here and let's come up with those approximations. So we have 4.73. That's going to help us when we actually go to graph. 1.270. All right, so those are our zeros. These are exact. These are approximate. All right, let's find our y-intercept. And to find the y-intercept, we are going to set x to 0. So to find the y-intercept, we set x equal to 0. So we have f of 0 equals -5, 0 minus 3 squared plus 15. And we're not subtracting 15 and doing all that now. We're just evaluating. So we're just going to follow order of operations. So -5 times, well, 0 minus 3 is -3. -3 squared is 9 plus 15. So -45 plus 15. and that's negative 30. So my y-intercept is 0, negative 30. Right, we'll have to make a really big graph for that. All right, let's graph it right here. Here we go. All right, so my vertex is, let me go back up, 315. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here we go. My zeros are 4.73, so 1, 2, 3, 4, so somewhere around here. The other one's at 1.27. I'm going to draw my axis of symmetry in at 3. My y-intercept's way down here at negative 30. There we go. So let's graph the best we can. And go in here, and to connect that fifth point, we're 1, 2, 3, we're 3 units away from the axis of symmetry. So 1, 2, 3, I'm going to be out here. All right, let's come up with our domain. So the domain for all of these is negative infinity to infinity. My range, well, my range is always going to be my smallest y. My smallest y, you can't see it. We're not going to have one, so it's negative infinity. And the biggest y I'll have is up at 15. And we put brackets because 15 is a possibility that we could get. My interval of increase, well, my interval of increase is as I'm coming up here, you know, where am I going until? So my x's going from here all the way to here, the graph is increasing. So these x's are coming from negative infinity, and the x's are going until I hit 3. And that's just parentheses. And my interval of decrease is going to be 3 to infinity. Remember that these are x values. They are not coordinate points. They are pieces of the domain. They are parts of the domain where the graph is either the value of y is going increasing or the value of y is decreasing. And the value of y is decreasing over this entire chunk of x's from 3 to infinity. All right, let's fill in the absolute maximum. The absolute maximum value is 15. The absolute minimum value is none. That's supposed to say none, but that doesn't look very good. Let's see. Oh, I don't know what's happening, but that should say none. And let's talk about the end behavior. The end behavior as x approaches infinity. Remember, those are the only two options. As x approaches negative infinity or infinity, y approaches, in this case, as x gets really big, y gets small, so negative infinity. And then it also goes to negative infinity in that direction as well. So that should cover everything. End behavior, absolute max, absolute min, interval of increase, decrease, domain, range, y-intercept, zeros, vertex, and axis of symmetry, and also with the 5 points on the graph. The zeros are here, the vertex is here, and then these are my 2 symmetric points. One is the y-intercept, and one is just that many units away from the axis of symmetry.